వస్తాను సార్ మంగళవారం సాయంత్రం ఫోన్
See?
ఇవాళ రాజు వస్తాను.
Very good morning. So am I audible?
Yes, sir. Sir.
Okay, let's start our session. So in the last class, we have seen the long transmission line and voltage and current values. So we have derived the equations for voltage and current, taking VR and IR as references. We have derived equations for sending end voltage and also sending end current. And also ABCD parameters for a long transmission line using distributed parameters. In the next class, we have seen surge impedance loading, and reflected voltage, reflected wave, and incident wave for voltage and currents. Okay. So now, in today's class, we are going to discuss about nominal T and nominal pi model of a long transmission. So nominal T and a nominal pi model of long transmission line. Okay. So for long transmission line, we have defined long transmission line and also analysis of long transmission line. That means considering a small section, a small portion. So we have derived equations. So this is the impedance, series impedance and shunt impedance values in case of short transmission line, so which is of length delta x. Okay, where delta x is small portion of long transmission line, in which the small z represents the length of impedance, series impedance per unit length. Similarly, small y represents shunt admittance per unit length, whereas length of the transmission line, capital Z, which is equals to small z into L, which is again the total series impedance, capital Y is total shunt admittance. Okay, so using rigorous method, we have developed equations. V is equals to, in terms of VR and IR, similarly I means on sending end side, voltage and current on sending end side. So whereas in terms of taking VR and IR as reference. Okay, in terms of sinusoid trigonometric functions, so using sine hyperbolic, so the equations can be written as V is equal to VR into sine h gamma x plus IR ZC sine h gamma x, where gamma is propagation constant, ZC is characteristic impedance. Okay. So these are the values we have obtained for voltage and current. Now today's class we are going to discuss about the equivalent circuit representation of a long transmission line. Again, we can, for our convenience, we can model the same transmission line using distributed parameters. So we can model the long transmission line into equivalent pi and also the equivalent T models. Okay. So, but the nominal T and nominal pi circuits does not represent the line exactly. So it won't give the nominal pi and nominal T does not represent the exact model of the long transmission line. So they do not account for parameters of the line being uniformly distributed. Okay. So these are the equations if we consider the distributed parameters, impedance, admittance values as distributed parameters. So we have obtained Vs is equal to Vr into cos h gamma L plus IR into Zc sin h gamma L. Similarly, sending in current values. So in terms of receiving end and receiving end voltage and receiving end current. So this we have obtained using rigorous method analysis. Okay. Now using these equations and equivalent pi models, we can derive the distributed parameters. We can express the distributed lumped parameters in terms of distributed parameters. Okay. Lumped parameters means so total impedance value. So total impedance of the transmission. That is in terms of distributed parameters. Distributed parameters means in terms of small z and small y. Okay. Now our aim is to find out the equivalent T and equivalent pi models. Those are equivalent models. Okay. Nominal T and nominal pi models are gives the exact values, whereas equivalent pi and equivalent T represents for a short transmission line, it gives the approximate values, it won't give the exact values. But up to 250 kilometers of line we can use nominal pi model or equivalent pi model, and equivalent T model can be used up to 250 kilometers of a transmission. So now our aim is to find out the equivalent pi representation of a long transmission. Here what I have considered the nominal pi means the total impedance series values are considered as a single impedance, whereas that is represented by Z dash. So if we use Z, that is a lumped parameter. Here that is not a lumped parameter Z dash. We have considered the series total series impedance as Z dash, whereas the shunt admittance values y dash by 2 and so y dash by 2, 2 halves. The admittance values are divided into 2 halves. One half is connected at the sending end, other half is connected at the receiving end. This is nothing but a delta model or a pi model. Okay. So where the sending end voltage is Vs, sending end current is Is, receiving end voltage is IR, sending end voltage is receiving end current is IR. Okay. Now, so we have already known these equations. We have derived these equations using a rigorous model. These are the sending end voltage, sending end currents, sending end voltage, sending end currents in terms of receiving end voltage and receiving end currents. Okay, that we have obtained for a long transmission. Now again, if we apply KVL and KCL, we have derived in case of nominal pi model. So in nominal pi model, the first step we have obtained the current passing through this branch, shunt branch, IC2 that is. So current passing through shunt branch. So we have calculated IC2 value. This is IC1. Here it is IC2. Okay. So by applying, say, am I audible? Anybody please respond?
Yes, sir.
Yes, sir.
సో వినిపించకపోతే చెప్పండి ఇమీడియట్గా, ఎందుకంటే ఇంటర్నెట్ కనెక్షన్ కాలేజ్ది కొంచెం స్లోగా ఉంటుంది. ఏమైనా లాగింగ్ వచ్చినా ఇమీడియట్గా ఇన్ఫార్మ్ చేయండి. ఓకే, సో వీఆర్ just we have calculated this in case of nominal nominal pi model for a medium transmission line. So we have calculated current passing through this, that is voltage at this point, that is VR. Voltage at this point is Vs, since voltage across this is Vs, voltage across this is VR. So once we obtained IC1, this is IC1, so IC1 is current passing through shunt branch. So voltage divided by voltage multiplied with admittance, you will get current passing through this. Once we know current passing through this plus IR directly gives current passing through this, which is termed as I1 or IL previously. Okay, so once we get I1 value, I1 multiplied with Z dash, you will get voltage across this impedance. Okay, so voltage across this impedance, once we get that one, again voltage across this impedance plus VR directly gives Vs value. So by applying Kirchhoff's voltage law and Kirchhoff's current law, okay, so we have derived equations for Vs and Is in terms of VR, IR. Again VR and IR. So we have derived the equivalent pi model for this. We have derived equations for this equivalent pi representation. Is it clear? That we have already done in short medium transmission lines. The same thing I am using, just by putting instead of Z, we have to represent Z dash. By representing Y, we can represent it with Y dash. Okay. So now the next step, directly I have written these equations. Okay, if you want, you can derive or you can copy from the medium transmission lines. Nominal T model, we have derived these equations and we have obtained ABCD parameters for the nominal pi model. The same thing, same procedure we have to follow, but here Y dash and Z dash are the shunt branch impedance, similarly series branch impedance values. Okay. Now again for a long transmission line, we have derived these equations using rigorous analysis. So rigorous method, we have derived these equations. This is using Kirchhoff's voltage law and current law for equivalent pi. So if we observe both the equations, this is sending end voltage, here it is also sending end voltage. If I want to derive an equivalent pi model, okay, so equivalent pi model, we have to find out Y dash Z dash in terms of cos H gamma L and sin H gamma or ZC into sin H gamma L. Okay, so this is the equations obtained from equivalent pi model. So here these are the equations obtained from rigorous method. So both the equations are for same long transmission line. If I want to derive the equivalent model for this, so equating these two or comparing these four equations, so will get 1 plus Y dash Z dash by 2, Y dash Z dash by 2 with these equations. So these are the equations obtained from rigorous method. Here these are the equations obtained from equivalent pi model. So equating these two, so if we observe, these are the values. 1 plus Y dash Z dash by 2 is equal to cos H gamma L, Z dash is equal to ZC sin H gamma L, and the fourth this term y dash into 1 plus y dash z dash by 4, which is equal to sine h gamma l by z. Okay, so this is 1 plus y dash z dash by the fourth term. If I compare the quotients of receiving and current IR and IR, so you will get 1 plus y dash z dash by 2 is equal to cos h. So once we get these equations, now the second equation, using the second equation, z dash is equal to directly z characteristic impedance multiplied with sine h gamma l. Okay, so that I have taken. So now multiply, if I substitute ZC value, what is ZC? ZC is characteristic impedance, which is small z by small y per unit values, otherwise for a short transmission line, and this is the impedance. These are the distributed parameters. So for a small portion of the line, z small z by small y, and here if I substitute gamma is equal to under square root of propagation constant under square root of yz. So and now, so I have divided and multiplied with this propagation constant or root yz, and similarly if we multiply and divide with length of the transmission line, so you will get this root z into root z, you will get z value. So similarly multiplied with length, so root y gets cancelled, denominator this can be replaced with gamma l. Now the entire equation is converted in this form. So where z dash is the series equivalent impedance in nominal pi, which is equal to, what is z? Small z is impedance for a long distributed parameter. Here it is impedance per unit length of the transmission line multiplied with L length. So it gives the total impedance, that is capital Z, where capital Z is the total impedance of the series impedance of the transmission line. So that is a lumped parameter, what we have assumed, capital Z, sine h gamma l by l. So that is replaced with capital Z, that is total impedance of the transmission line, Z into sine h gamma l by gamma l. Okay, if we observe these equations, Z dash is equal to Z into sine h gamma l by gamma l, where Z is lumped parameter, so Z dash is distributed parameter. So if I want to find out the series impedance of a long transmission line in a nominal, in an equivalent pi model, so where Z dash is equal to, so this lumped parameter multiplied with sine h gamma l by gamma l, if we multiply with this fraction, this part, so the lumped parameters are converted into an equivalent values, almost equivalent values of distributed parameters. Okay, so here this means to get the equivalent series impedance, the lumped impedance capital Z should be multiplied by sine h gamma l by gamma l. Okay, is it clear? Okay, next we have to find out shunt branch parameters, that is shunt branch impedance, that is y dash by 2. So for that we have to take the second. So in the previous equations, these are the equations, 1 plus y dash z dash by 2 is equal to cos h gamma l. Okay, so we have obtained by comparing these two equations, the first equation, which is 1 plus y dash z dash by 2, which is equal to cos h gamma l. Now taking the first two equations, okay, here taking the second equation, we have derived the series impedance in terms of equivalent series impedance in terms of lumped parameters. Now we have to find out the shunt admittance, equivalent shunt admittance in terms of lumped parameters. Again, the same equation, y dash z dash by 2 here, z dash we have already obtained z dash value which is equal to z into sin h gamma l by gamma l. That we have to substitute here. Okay. So which is equal to cos h gamma l. So okay, substituting z dash, not this one. So if we substitute this, zc into sin h gamma l. So zc into sin h gamma l which is equal to cos h gamma l, substituting z dash value. So from second equation, substituting in this, so you will get y dash by z is equal to zc into sin h gamma l into cos h gamma l minus 1, taking the 1 on to right hand side, cos h gamma l minus 1. So now we have trigonometric equations, hyperbolic equations. So this can be written as 2 sines h square gamma l by 2. So we have hyperbolic equations. Cos h 2x is equal to cos h square x plus sin h square x. Okay. Using the second relation, if we observe the second relation, cos h 2x is equal, can be written as 1 plus 2 sin h square x. Otherwise, if it is x, this becomes x by 2. If it is theta, theta by 2. Cos h theta, it can be written as 1 plus 2 sin h square theta by 2. The same thing here, theta, what we have assumed, that is gamma. Okay. Now, using the same formula, I have substituted 2 sin h square gamma l by 2. Okay. Now, next step, y dash by 2 is equal to, this is y dash by 2. Now taking on to right side, that becomes 1 by zc. Okay, this sin h gamma l can be written as 2 sin h gamma l by 2 into cos h gamma l by 2. Sin gets cancelled. You will get cos here. Cos, if we take on to right hand side, that becomes tan h gamma l by 2. Okay. So simply I have written sin theta, sin h theta can be written as 2 sin h theta by 2 cos h theta by 2. Using the same formula I have not given here. So same formula we have used. So here if we write sin into cos, sin gets cancelled. So you will have sin divided by cos. So finally you will get y dash by 2 is equal to 1 by zc sin h gamma l by 2. Okay. And square root of y by z into. So now the same equation. So here, so I have replaced zc with characteristic impedance. Characteristic impedance is root z by z, root z by y. So 1 by means that becomes root y by z. So multiply and again multiply and divide with gamma by 2. Gamma means root yz by 2 and root yz by 2. If we multiply and divide with this. So now the entire equation this can be written as, so now y, square root of y into square root of y, you will get y. That multiplied with L. Here L is outside the root. Okay. So we multiply and divide with L. It is not inside the root. It is outside the root. So root z will get cancelled. Root y into root y becomes small y into L. That is length of the transmission line. Small y is admittance per unit for a short transmission line. So that multiplied with L, you will get total admittance. Okay, this is lumped admittance. That divided by 2. So if we observe, so this is the final value. So if I want to find out the shunt equivalent, in equivalent pi model, which is equal to, this is lumped parameter. In case of uh, shunt branch, that is its admittance value is y by 2. So if we multiply with tan h gamma L by 2 whole divided by gamma L by 2, so these lumped parameters can be converted into equivalent admittance in case of long transmission lines. So if you please note down, these are very, very, very important values. Okay, just a minute. మార్చారా ఏ డేట్లు ఏం మార్చలేదు. Okay, so these are the shunt branch parameters, that is y dash by 2 is equal to in terms of lumped parameters. This y is lumped parameter, so y dash is equivalent parameter in case of a long transmission. Okay, this means to get an equivalent series impedance, the lumped impedance should be multiplied with by sin h gamma L by 2 by gamma L. So similarly, the total shunt admittance, where y is the total shunt admittance, that means to get the shunt arm of equivalent pi, the shunt arm of nominal pi should be multiplied by tan h gamma L by 2. Here it is something, it is missing. Here we have to write by 2. Tan h gamma L by 2 whole divided by gamma L by 2. Okay. Now this is the equivalent pi representation of a long transmission line. So we have just followed what we have done in the earlier by applying Kirchhoff's voltage law and current law. The first step, we have to find out sending end voltage and sending end current equations in terms of receiving end voltage and receiving end current values. So keeping aside, next the second step. So the equations obtained from the rigorous method, that we have written the same voltage, sending end voltage equation and also the sending end current equations. Comparing these two, okay, and rearranging the terms. I have not done anything, just rearranging the terms. Finally, you will get the equivalent pi model in terms of lumped parameters, where z and y are the lumped parameters. So if we multiply with this fraction, this is tan h gamma L by 2 and gamma L by 2 whole divided by gamma L by 2. Similarly, here the impedance, series impedance is multiplied with sin h gamma L by gamma L. That entire thing can be converted into an equivalent pi representation. So this is very easy method. So if we go for rigorous solution, again we have to call so many complex numbers we have to calculate. Whereas if we use this, so we can simplify the analysis and also the values, but these are not the exact values. It gives the approximately the best values. Okay, now the same procedure we have to obtain for nominal T, equivalent T, to get the equivalent T representation of the long transmission. Now we have derived equivalent pi model. The same procedure we have to follow while deriving equivalent T representation. So try to solve that one. Try చేయండి. So first step ఏం చేయాలి? Okay. Here to determine the equivalent T, we have to first consider the following. The same thing, equivalent T means the total series impedance is divided into two halves. One is Z dash by 2, because these parameters are not the lumped parameters, that's why I have used Z dash by 2. So shunt branch parameter is Y dash. Okay, again same. So one more mistake here, it is V receiving end voltage, receiving end current, V receiving end voltage, so receiving end current. Okay. Now again the same. So using rigorous method. So in the previous nominal D model, we have obtained these equations. So same thing we have obtained again by applying Kirchhoff's voltage law and Kirchhoff's current law. We have obtained two equations, that is Vs is equal to 1 plus Y dash Z dash by 2 into Vr plus Z dash into 1 plus Y dash Z dash by 4 into IR. Is is equal to V dash into Vr plus 1 plus Y dash Z dash by 2 into IR. So how you got these equations? Just by applying mesh analysis or nodal analysis, whatever it may be. So finally we have to write voltage, V sending end voltage in terms of receiving end voltage and receiving end current. Similarly, I sending end current is in terms of receiving end voltage and receiving end current. Either by applying Kirchhoff's voltage law or current law, we can get that just. So we have derived in case of medium transmission. The same thing I have copied here, the same values. Instead of Y, Y dash. Instead of Z, we have used Z dash. Okay, if you have any doubt, you can ask. The values already మనం derive చేసాము, కావాలంటే previous వాటికి వెళ్ళండి. Derivation. Okay. So have you written? రాసుకుంటే నెక్స్ట్ స్టెప్కి వెళ్తాను. So again from the rigorous method, we have two equations, that is, so previous case, the same equations I have written here, that's why I have not written. So these are the equations. Again from the rigorous method, we have these two equations. Vs is equal to, okay, so here these are the two equations. Okay, so comparing now again, these are the equations for a long transmission line using rigorous method. So these are the equations just by applying Kirchhoff's laws to the circuit, and we have obtained the relation Vs and Is in terms of Vr and IR. Okay, again comparing these two equations. So if we compare, so Vs sending end voltage, Vr is receiving end voltage, cos h gamma L is equal to 1 plus y dash z dash by 2. Okay, similarly here Zc, the quotient of IR receiving end current, that is Zc into sin h gamma L, which is equal to z dash into 1 plus y dash z dash by 4. So comparing these quotients and writing the equations, finally, okay, have you written? Okay, so now comparing the equations, you will get the equations as, so 1 plus y dash z dash by 2, the first equation which is equal to cos h gamma L by 2. The second equation as z dash into 1 plus y dash z dash by 4, which is equal to zc into sin h gamma L. Okay, so y dash is equal to, now using third equation, if I observe this third equation, so that is what y dash is equal to sin h gamma L by zc. First taking this equation, next to get the shunt branch parameters, this is admittance value. Here in nominal, in equivalent T, so first we have to get the shunt branch, that is admittance. So equivalent shunt branch in terms of lumped parameters. Next, after that, we have to substitute this y dash in first equation, you will get z dash value. Okay, first we have to rewrite this equation as, to determine the shunt branch of equivalent T, so y dash is equal to 1 by Zc sin h gamma L, which can be written as, so again Zc means, again substituting the same formula, characteristic impedance formula, small y by small z, and again multiply and divide with root yz into L. So this root y into root y, that becomes small y, root z gets cancelled, small y into L, small y is admittance per unit length multiplied with length, it gives the entire admittance value. So finally we can written as capital Y into sin h gamma L by gamma L. Okay, is it clear? Next, simply the same thing. To get the shunt branch parameters of equivalent T, the shunt branch of nominal T, that is lumped shunt admittance, should be multiplied by a factor sin h gamma L by gamma L. So here we have to multiply, if we multiply this shunt admittance or lumped admittance, multiply with this factor, you will get an equivalent shunt branch admittance for a long transmission. Next, to get the series impedance of nominal of equivalent T. Now, taking the equation, first equation, and substituting the third equation in first equation, you will get 1 plus z dash by 2 into sin h gamma L by zc, which is equal to cos h gamma. So again same thing, cos h gamma L minus 1. So if we substitute, that is z dash by 2 into 2 cos theta by 2 sin theta by 2, cos h theta by 2 into sin h theta by 2. So that is sin h theta is equal to, can be written using this formula, which is equal to, so cos h theta minus 1 can be written as 2 sin h square theta by 2. Again the same two formulas what I am repeating here. So that's why I have not given. Simply cos h theta minus 1 can be written as 2 sin h square theta by 2, and also sin h theta can be written as 2 sin h theta by 2 cos h theta by 2. So here theta is replaced by gamma. Okay. Now again the same thing, rearranging the terms. So cancel the sin h gamma l by 2 and taking cos h gamma l by 2 onto right side, it becomes zc into tan h gamma l by 2. So again if we observe the equations, so multiply and divide with root h gamma root yz into L. So again here L is outside this square root. So we have to just see here L by 2. L is outside the square root. So rearranging the terms, z dash by 2. What is z dash by 2? That is series branch impedance. Z dash by 2 and z dash by 2 in case of T model. So the total series impedance is divided into two halves. That's why z dash by 2, which is equal to z by 2 into. So again multiply with this factor. So here it is. This means that to get the series branch of the equivalent T circuit, the series branch of nominal T, that is lumped series impedance, should be multiplied by a factor of tan h gamma L by 2 whole divided by gamma L by 2. Okay, this is the equivalent T representation. So are you able to follow? If you have any doubts, you can come, can ask, can give a message. అర్థమవుతుందా? ఫాలో అవుతున్నారా? So I have given you assignment 1. So within a week you have to submit. Assignment 1 you have to submit within a week. That means by next Saturday. Okay. So try to complete. Try to solve. Examples, I have given 3 examples, 3 problems and 2 derivations. Try to solve that one. So based on course outcomes, so total, so the assignment 1 is making 3 outcomes. So first one, second one and third outcome. So I have given course outcomes in the same assignment. So try to solve that one and try to solve within time. If you have any doubts, you can ask. Do you have any doubt? Doubts ఉంటే చెప్పండి. డౌట్స్ లేకపోయినా చెప్పండి. డౌట్స్ లేవు సార్, క్లియర్గా ఉంది అని. డౌట్స్ ఉంటే చెప్పండి. ఇఫ్ యూ హ్యావ్ ఎనీ డౌట్స్ యూ కెన్ ఆస్క్. అదర్వైజ్ సింప్లీ యూ కెన్ ఎండ్ దిస్ సెషన్. Anybody wants to ask any doubts till now? ఇవాళ మిడ్ ఎగ్జామ్ పెట్టినా రాసేటట్టు ఉండాలి. ఓకే, థ్యాంక్ యూ.